In this video, we'll demonstrate how to use LINQ methods. Language Integrated Query, or LINQ, is a powerful feature in .NET for querying and managing data from various sources. Here are some key benefits of using LINQ. LINQ provides a clear and readable syntax that integrates seamlessly with the C# language, making it easier to understand and maintain. LINQ is strongly typed, which means that errors can be identified at compile time rather than at runtime. With LINQ, you can perform complex querying operations concisely. This reduces the amount of code you need to write and maintain. LINQ supports deferred execution, which means that the query is not executed until you iterate over the query variables. LINQ offers a robust set of operators for filtering, sorting, and grouping data. To demonstrate LINQ, we'll create a simple console app. We'll need a list of stuff to test LINQ on, so we added a class called student to hold some basic info about a student, like student number, first name and last name, the grade the student is in, and a list of 4 integer test scores. In the program CS file, to keep our main method clean, we added a method to generate a list of students. With our list of students created, let's write a LINQ query to give us all the students in grade 6. The LINQ format we're showing here is called the query format, and as you can see, it looks a lot like a query statement in SQL. Here we say for every S in the students list, where S is just a placeholder for each student, where the student's grade is equal to 6, select that student. And as expected, when we do a for each through the result, we get every student in grade 6. But the other LINQ format is the method format, which is a bit more concise. It has the benefit of chaining and embedding LINQ methods, as we'll see later in this video. LINQ methods use lambda expressions, and for those not familiar with lambda expressions, this may look a bit strange, but let's see how we read this statement. It says, in our students list, select students where every student, again represented by a placeholder S, has a grade equal to 6, and the result is still the same. For now, we'll be focusing on the method format of LINQ and look at all the available LINQ methods you can use to write simple and complex one-liner queries. But first, it's important to understand that the query you see here in line 9 does not execute immediately. This is just the definition of the query. The query only executes in the for each loop when it needs to access the elements in the result list. In other words, execution of the query is deferred until the result is actually needed. Let's quickly see this with an example. Here we got a simple list of integers. We define our query to select only values in the list greater than 3, but then we change the first value in the list to 99. Since the query hasn't run yet, when we loop through the elements, we find 99 as part of the result. But if we add a method to our query to convert it to a list, the query is executed immediately and saved to the result variable. Now, if we change a value in the original set, it won't affect the result value, and 99 is not part of the result variable. We'll come back to the where method in a moment, but first let's look at some other useful LINQ methods. Here are some aggregation methods. The first method is the any method. This looks through your data set and returns true if any of the elements in the set matches the lambda condition. In this case, it returns true. There's at least one student in the list that's in grade 5. Next is the all method. This asks if all of the elements meets the condition. Since all of the students are not in grade 5, the result is false. The next 4 statements are self-explanatory. Here we use the sum method to sum the first test score of all the students. Then we average the first score of all the students. We can find the maximum first test score in our list of students, and of course the minimum first score. Back to the where method. Let's see how we can embed LINQ methods into our lambda statement to create a little bit more complex query. Here we ask the question, give me all the students in grade 7 who has any test score that is below 75. In our lambda expression, we first select all students with a grade equal to 7, Then we use a normal AND operator and check are any of that student's score below 75. As the result shows, we found 2 students with a test score below 75. As mentioned before, we can also chain link methods together. In this query, we want to order all our students by the grade they are in, then order them by last name, and finally order them by first name, but in descending order. Here we just show the then by descending method, but both order by and then by comes in ascending and descending flavors. Also, we could have used a where clause first and then added all the order methods onto this. The point of this is to demonstrate how easily you can chain link methods onto each other. The result, of course, is an order by grade, then last name, and as you can see, the first names are then in descending order. There's still more link methods. In this example, we use the select method to project a single student property into a list. Here we get a list of all the student numbers. Another projection method is select many. Since the scores property of a student is an integer array, if we only used the select method on the scores property, it would have given us a list of arrays. But with the select many method, it treats every score value as a separate element and returns a list of all the score values instead. You can also use filters in your lambda expressions. Here we use starts with and ends with filters. The query asks, give us all the students whose last name either starts with an uppercase J or ends with a lowercase e. The other filter method is contains. The query asks, give us all the students whose first name contains either the lowercase letter a or the uppercase letter a. Like all queries, at some point you would want to join tables or entities. To demonstrate how to join entities with a LINQ statement, we'll add another class called courses. This will simply hold the course ID and the course name. In our students class, we'll add a course ID property to reference one of these courses. Back in the program class, like with the students, we added a method to generate a list of courses for us, and added a value for the course ID property in the list of students. On top in the main method, we call these methods to generate our students and courses lists. In our query, we say, use the students list and join in the courses list. Then we give it 2 arguments. The first is the property in the first list, and the second is the property in the second list that forms the relation between the 2 entities. After that, we're saying use placeholders S and C, which correspond to the first and second list, and give us the first name and last name from students and the course name from courses. Now we can iterate through our query result and display the joined fields. The next common action in a query is to group our selection. Here we use the group by method to get all our students, but group them by their course ID. This creates a sort of dictionary for us with the course ID as the key and a list of students as its value. We iterate through the courses and display the key value in this dictionary. Then we iterate through every student in its student list value and display the students for that dictionary item. But this is just the student list. What if we want to group and join with the courses list? In this query, we start with the courses list, then group join them to the students list. We specify the properties in each list that forms the relationship between the 2 lists. Then we say, for every course and collection of students that are part of that course, select the students and course name into new variables. Again, we can iterate through the courses and now display the course name. Then iterate through the students property and display the students associated with that course. So far, we've covered the most common methods you'll probably use to create a LINQ query. But to make this video complete, let's look at the remaining LINQ methods that you may find useful. The first method simply finds the first element that satisfies the lambda expression. The last method obviously finds the last element the query encounters that satisfies the LINQ query. Then there's also the single and single or default methods. The single method will return the first element that matches the lambda expression, otherwise it will throw an exception. The single or default method will either return the first element that matches the expression, otherwise it will return a null or object with default values. Here we show the single or default method that will return a single student with the last name Jones. The second example will try to find a single student with the last name XYZ, and since it doesn't exist, it will return an empty record. At some point, you may want to implement pagination in your application, where you only display a certain number of items in a list at one time. LINQ helps with pagination logic in the form of the skip and take methods. The skip method will skip over a number of items and then return whatever remaining items there are in the list. Here we skipped over the first 3 students and returned the remaining students. The take method will only return the number of items you specify. Here we only wanted to take 3 students from the list and display them. Of course, you can chain these methods together to skip some pages and only take the number of items to display for the next page. Here we skipped the first 2 students and took the next 3 students for our result list. There's also a strange method called skip while. The skip while method only works on the first item on the list. It will otherwise return all records. The simplest example I could think of is when you have a list and the first item is something like a headers item. To demonstrate this method, we inserted a header row at the first index of our students list and set the student number to 0. Now when we execute a skip while method, we can ensure we skip any first item where the student number is 0. This is a bit of an odd method, but I'm sure you'll find more creative ways of using it. We've covered quite a lot of methods, but I promise these are the last few LINQ methods. The element at method will return the item at the specified index in the list. And the element at or default method will return the item at the specified index, or if the index doesn't exist, will return the default value for the item. Since we're using lists of integers, the return default value will be 0. Finally, there's the sequence equal method. This will compare 2 lists, and if the count of elements is the same and the value of the items are the same, the lists match and it will return true. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.